Hey guys, welcome to CodeChef's YouTube channel. The problem that we're going to solve today is subarray sum. The problem appeared in Starter 16 of October 21 and is a difficulty level of easy medium. The prerequisites to solve this problem include stack and dynamic programming. The problem statement goes as follows. Chef has a sequence of n integers that is from a1 to an. Now he defines a function f of ij as follows. It is the element ai plus maximum of ai comma ai plus 1, then maximum of ai and the next two elements, and so on up till maximum of elements from ai till aj. So since all the other terms are in terms of maximum, that is maximum of ai to some ajth element, actually we can write the first element, that is the single element ai, as simply maximum of ai. That is, the sequence contains only one element, so it is itself the maximum. So don't see it as one element as separate and other elements as maximum of range of elements. No, you can see the first element in terms of maximum as well, just that the sequence contains only one element. So this is one simple observation. Further, chef tries to find the sum of f of ij over all I comma j, that is over all ordered pairs I comma j where j is greater than equal to I. Chef tries to find the sum of f of ij. In mathematical terms, it can be written like this, but fails. So our task is to help chef help chef find this sum. So basically we have to find this quantity summation, double summation from I is equals to 1 to n, j is equals to 1 I to n f of ij. And since this number can be very large, we have to find it modulo 10 to the power 9 plus 7. So this is basically the task. Solving it for a sample test case is very easy. Basically, you have to just take an array. Okay, you can do it by yourself for a smaller array, but the thing is that there are many terms in f of ij itself. And now, if we are finding the f of ij for all possible I comma j, there will be even more terms. So the main problem over here is how to optimize the solution. Okay, brute solution is never going to work. That is, manually you cannot find all these values, max of ai comma ai plus 1, max of ai comma ai plus 1, ai plus 2. This you cannot afford to do it manually for each I and each j, because that will be time taking and not fitting the time complexity. So also, it is given over here that since the input size is large, it is preferred to use the fast IO methods in your respective languages. So keep that in mind. And now let's see how to approach the solution. The solution approach goes as follows. First of all, we need to observe that what terms comprise of our answer. Okay, so the answer is going to be consisting of terms like all possible f of I comma j, right? Basically we want the summation of values of f of ij where j is greater than equal to I and all such pairs are considered. Also, f of ij, as we know, is max of ai, then we have max of ai comma ai plus 1, and so on up to all these values are added up to maximum of ai to ajth element. Okay, so there is a repetition of these individual terms which contribute f of ij. How? You can see that if I define, let's say I'm defining my own term. That term is called as max I comma j. What max of I comma j denotes? Max of I comma j denotes the maximum value from aith element to ajth element. Okay, so this max I comma j, this term is present of multiple f terms. How? Clearly you can see that f of I comma j, this contains max I comma j. Okay, then again f of I comma j plus 1 also contains this. Again, f of I comma j plus 2. Okay, so multiple such terms all the way up to f of I comma n. All these terms contain our term max of I comma j. So each such max of I comma j term is part of how many such f terms. If you calculate, the value of j starts from j and goes all the way up to n. So basically these are total n plus 1 minus j terms. Okay, so each max I comma j term is considered how many times? N minus j plus 1. And like this we have to calculate the sum over all I comma j's. So now our question can be reformulated in mathematical terms. That is, initially what we had the question? The question was initially to find this value, that is summation I is equals to 1 to n, then j is equals to I to n f of I comma j, where the definition of f of ij is given in the question. Okay, now we can reformulate this as summation I is equals to 1 to n, j is equals to I to n. Okay, we can call this g of I comma j, where what is g of I comma j? Now g of I comma j is basically max of I comma j, that is maximum of elements between aith and ajth element, and this term is present of many f terms. So this has to be multiplied with what? It has to be multiplied with n minus j plus 1. So again, if you simplify, what does our expression look like? Our expression will look like double summation max I comma j multiplied with n minus j plus 1, where this is the summation for j, this is the summation for I, and like this. So in mathematical terms, we have reformulated the question. Now, this value can be found out efficiently if we use the concept of dynamic programming, but for that you need to know a well-known problem, that is finding the next greater element. Let's see how to use that to our knowledge and simplify and optimize this expression. So our task now is converted to this, that is we need to find the value of this mathematical expression. So for finding the value of this, let me define the value of dp of I. So I am defining dp of I as summation j equals to I to n max of I comma j into n plus 1 minus j. So basically this part, okay, the leaving the outer summation, whatever is the value present in the inner summation, that is basically my dp of I. I am considering it for time being. Okay, so what is going to be my answer? My final answer is basically now dp of 1 plus dp of 2 all the way up to dp of n, because this is just the outer summation, right? Outer summation and inner summation is basically dp of I. So my final answer is now going to be summation of all the values present in the dp array. But for that we need to calculate these values individually. Now dynamic programming involves getting the answers for sub problems that are already calculated. Okay, so that we don't do recalculation of same terms again and again. So here, because the indices vary from the current index to the last index, it is quite intuitive that we should start iterating over I from the last index. Okay, that is, first I should find the value of dp of n, then I should find the value of dp of n minus 1, and so on. Also, why that is helpful, you will see just now. So this is the expression, that is dp of I is equals to summation j is equals to I to n max ij into n plus 1 minus j. I can break this into two parts. Okay, how I can break this into two parts? So you might be wondering how you will get the idea. So for that you must know the problem of next greater element. Okay, that is a well-known problem. So if you know that, you will get the idea to break this into two subparts. Now what are those two subparts? First of all, for dp of I, we will see that for what ranges is ai the maximum element. Okay, so the elements from I to last element will be as follows, right? The element will be ai plus 1, ai plus 2, all the way up to an. Okay, so the first element in our range, that is the element ai, it will be the maximum till some range, right? That is maximum of ai comma ai plus 1 is also ai. Okay, for first three elements also it is ai, for first four elements also it is ai, like that till some index ai will be the greatest element. How to find that? So that is basically finding the next greater elements index. So if ai is my current element, then what does next greater element problem tell us? The next greater element problem tells us the next index that is greater than I and has a value greater than or equal to ai. So what does this problem tell us? It gives us an element at index ind such that this element is greater than ai. Okay, the first element to the right of ai, okay, towards the right, such that it is greater than or equal to ai. Okay, so this is what we get from the next greater element problem. How can we use that to our help? Now once we know this info, assuming that the next greater element lies at the index a of ind, we can further divide our expression of dp of I in the following manner, that is summation j is equals to I to ind minus 1 from to till all these indices, that is from j is equals to I to ind minus 1, ai will be the maximum of I comma j. That is for sure. Why? Because the next greater element is is present at index a of ind. So we can simply write over here ai into n plus 1 minus j. Okay, this we can write, and for the remaining terms, what will it be? It will be again max of I comma j, and j will vary from ind to n, and it will be multiplied with n plus 1 minus j. So we have now divided our expression into two subparts. Okay, this is the first subpart, this is the second subpart. Now if you are uh, observing it carefully, in the first subpart you can clearly see that ai is a constant value, so you can take it outside summation. What I mean by that, this is a constant value, so you can just take it over here, right? ai can be taken easily over here. And in the second term, if you observe, what is the maximum from I to jth element? This was element ai, this was element ai plus 1, ai plus 2, all the way up to I and d, and then we have an over here. Now we know one thing, this is element ai and this is the next greater element. Okay, so if our range I comma j, if j lies over here, okay, so the left bracket will be somewhere over here if I represent the range, and the right bracket will be over here, right, for the second term, because j varies from ind to n. So definitely the maximum term is not going to be amongst these elements. Why? Because a of ind is definitely greater than a of I, because that's what the next greater element problem gives us. So rather what we can do is, instead of writing it as max of I comma j, what we can write it, we can write it as max of ind comma j. So if I just replace this max of I comma j is now actually max of ind comma j. And now you may see some similarity in our dynamic programming problem. What was dp of I initially defined as? If you go up, dp of I was defined as j is equals to I to n max of I comma j into n plus 1 minus j. And here if you see, this is exactly the same thing. This second term, okay, this second term is exactly the same thing, just that instead of dp of I, it is dp of ind. So this whole thing is already pre-calculated. Why? Because ind is an index present to the right of I, and because we are iterating from right to left for I, this is pre-calculated. So how we can again restate our mathematical expression? Finally, our mathematical expression is going to look like this. dp of I is equals to a of I into summation j is equals to I to ind minus 1. Here we have n plus 1 minus j, this value, and plus we have dp of ind. So our whole problem has now come down to this expression. Now how to calculate this? This will be calculated, pre-calculated, so we'll just take it from our dp array. The question lies how to calculate this part. Now again, this is a constant, ai is a constant, so that does not worry me. I have to only calculate this summation part. So let's separately calculate this summation. So how does the summation look? The summation is summation j is equals to I to ind minus 1 n plus 1 minus j. Again, n plus 1 is a constant, so n plus 1 can be taken out. So taken out with the multiplication. So how to do that? Basic maths. Uh, we have it like n plus 1 will be calculated how many times? These are how many terms? These are basically ind minus j terms, right? So ind minus j terms we have over here. J actually begins with I, so actually we can say it like ind minus I terms actually. Okay, so this, and we have to subtract from this what? We have to subtract from this summation j is equals to I to ind minus 1 j. So this is a very easy thing to do in maths. So that can be now written as, you have to basically calculate the sum from 1 to this index and subtract this sum from 1 to this index minus 1. So that can be done as follows. You have to do basically ind into ind minus 1 by 2. Okay, and you have to subtract from this I into I minus 1 divided by 2. So there you have it. All things are simplified into simple terms. Okay, the summation that you can see in blue color, finally we have got this in easy terms. I can write it in the red box. So whatever you can see in the red box, that is basically the simplification of the blue text. Okay, and there we have it. If you put all things together from the dp formula to this, now this can be coded easily, and we can do it in order of n time using the stack concept. So what is the stack concept? So for basically for getting the next greater element, so The question that might arise in your mind is that how to get this index IND, because everything depends on this index IND now, right? So this index can be easily obtained using the stack method for the next greater element problem. If you don't know this standard problem, you can Google it. It is very easy. You might also understand it in the implementation that we are just about to see. So now that the explanation is clear, we'll see the implementation right away. So the implementation goes as follows. Uh, we have the number of test cases. Then for each test case, we take the input for n and the array. I take the array input and then I create a DP array. And you might see that I have created it for a slightly bigger length, that is n plus 5. Why? Because for the last index, I need to access an index which is even to the right of that. So if that index does not exist, I'll get some garbage value. I don't want that. So for that purpose, I'm creating a slightly bigger DP array. Now I have the stack for calculating the next greater element index, and we start our iteration of I from right to left, that is backwards. Okay. Now initially the stack is empty, but for each index, what we do, we keep on popping the elements from the stack unless we get an element that is greater than or equal to our current element. So until the stack's elements are less than our current element, we keep on popping them. So this way, what happens is that at the end of this while loop, when we come out from this while loop, whatever element is present at the top of the stack, that index is my next greater elements index. Okay. So initially, because the stack is empty, this while loop will not work at all, and I'll have to set some default value for IND. So that value is n plus 1. Okay, because for nth index, what is the next index? N plus 1, right? After that, but if the stack is not empty, it means that I have some next greater elements index, and that is basically stack top. Then after this, all things are done. For the further iterations of smaller I values, I need to push the current I in the stack. So that I do over here. And then this is the maths. Now you might be wondering that what we saw was little different and what you are seeing here is different. But they are actually the same. If you see over here, we are multiplying n plus 1 into IND minus I. Okay, so this is the term 1. This you can see over here. Okay, I have multiplied these two terms. This function MUL is because we have to do all the operations modulo 10 to the power 9 plus 7. So these are my modulo operations which take care of all the modulo things. So I calculate this term first. Then I calculate the second term, that is IND into IND minus 1 divided by 2 minus I into I minus 1 divided by 2. So this term is calculated over here, as you can see. Okay, IND into IND minus 1 divided by 2, and I subtract from that the other term. Okay, so now that I have my term 1 and term 2, what I have to do? I have to subtract these terms from each other. Okay, term 2 from term 1. So that I do over here. The term 2 is subtracted from term 1, and also this whole thing has to be multiplied with AI, because as we saw over here, dp of I is basically AI multiplied with this whole thing. Okay, so we have to do that as well. So this gives my partial value of dp of I, and don't forget, in this whole thing we have to also add dp of IND. So again, that I do over here. So dp of I is add the partial value and add the dp of IND value. And dp of IND is already pre-calculated. Why? Because IND lies towards the right of I and we are iterating in backwards. So don't worry, IND value will exist. And if not exist, then we have a slightly bigger length array. So that is all handled. And finally, we add the value of dp of I to our answer, because what is our final answer? Our final answer is dp of 1 plus dp of 2 plus dp of 3 all the way up to dp of n. So we are just adding them, but in the reverse order. That is, first dp of n will get added, then dp of n minus 1 will get added, and so on. So this is basically the code. You can see over here that completes our implementation. So we can now submit the code on CodeChef ID to check the correctness of the code. So I will just copy the code and submit it over here. The language will be C++ 17 because uh, we are using the latest C++. And now we have to just wait for the verdict. Great. So our solution works. I hope you guys understood the problem as well as the implementation. If you have any doubts, you can ask them in the comments below. I'll try to answer as much as I can.